write and graph exponential functions. Okay, first of all, let's talk a little bit about this little formula right here. If b is bigger than 1, we will have a growth, okay, in our graph. All right. So let's look at some quick example here of what I want you to do. So y equals 2x plus 3. X and y. We're going to pick some points: -2, -1, 0, 1, and 2 for x. Everybody figure out what your y's are real quickly. Now, figure out the difference between all your x's and all your y's. This would be plus 2, plus 2, plus 2, and plus 2. In your x's and differences in your y's. Slope. Okay. 2. That's what it should be. Okay. This is what we call linear. It makes a straight line. We've been doing this all year, right? Okay. So let's take a look at an exponential function. Y equals 4 times 2 to the x. Now make an xy chart, and everybody figure these out. Want some help?
No, all you gotta do is plug it in, right?
Yeah. You really don't need a calculator. How much? Are you ready?
Well, I don't know what 4.2 times 4.2 is.
That's 4 times 2.
Oh, I thought it was 4.2.
Alright, so if the exponent's -2, to make it positive, I need to move it and the base to the opposite position. So really, this is going to be 1 over 4, isn't it? 2 squared is 4. This is a -2. 1 over 2 squared is 1/4, isn't it? Okay. So what is 4 times 1/4? 4. All right. 2 to the -1 is just 1/2. 1/2 times 4 is 2 to the 0 is 1 times 4 is 4. Thank you. 2 to the first is 2 times 4 is 8. 2 squared is 4. 4 times 4 is 16.
It's not straight.
It is not straight. Find out what the differences are, everybody. Left side, we're adding 1 on each one. What is going on the right side? What are we doing on the right side? Yeah, we're multiplying by 2. Whoa. This is exponential. All right. So let's just write a couple things here. Write a function rule. 1, you have to check to see if it is exponential. Just got to check to make sure. Obviously, if the x is in the exponential position. All right, number 2. Find A, this letter right here. Find A, a little quotation mark, by having x equals 0. Okay? So if we let x be 0 up here,
B equals
then that's 4, okay? So B, letter B, is what you multiply by in your y column. What do we multiply by on that one? In the y column. So this right here is B. Alright. That's letter A. The point is sometimes you don't have these. This is showing you how to find these things, okay? Obviously this is A, B. This is we already know the setup. Okay, so and then 3 is write your rule. Alright, so let's do a couple things here. Example 3. Here is your information. -2, -1, 0, 1, and 2. And then you have 3/16. You have 3/4, 3, 12, and 48. Now it's not written as an equation. So first of all, is it exponential? Just look at the numbers you do know. What are the differences here? What are you doing? Reggie?
times 4.
Multiplying by 4. Okay, well let's just check. Are we, if I multiply that by 4, what do I get?
3.
And if I multiply that by 4, what would I get?
3/4.
So, how do I figure out, what if they were all fractions? How would I figure out what I'm multiplying by?
Look at the.
Yeah,
Shouldn't the denominator be like,
it's easier than that. This, the second number divided by the first. What's 48 divided by 12?
4.
So you do the same thing with your fractions. If I took 3/4, divide by 3/16, that's the same thing as 3/4 times 16 over 3, isn't it? That's just 4. Okay, so use what you've been taught. Don't forget this stuff. All right, so, what did I just do? Is it exponential? Yes, it is. Find A by x equals 0. Well, that must be A. If x is 0, right? That's right. So y equals, A is 3, B is what you're multiplying by in the y column, 4, 3x. Just like your homework, right? We good? All right, 3 more examples. Example 4. Graph and identify the domain and range. So we're going to take this, y equals 4 times 3dx. And I want everybody to figure out -2, -1, 0, 1, and 2, and then try to graph it. I want to put the other examples up here because I want you to work on them if you get done. Do I need to go over this part again? With your negatives and stuff, just to make sure. Okay. So 3 to the negative 2. To make it positive, I drop this to the bottom. It's 3 squared, which is 9, right? Yes. 4 over 9 is what I'm saying. Okay, that's 4 ninths. So when x is negative 2, I'm going to make these fairly big here. When x is negative 2, I have 4 ninths, which is not quite, or excuse me, not quite a half. So it's about right there. When x is negative 1, 3 to the negative 1 means 1/3. 4 times 1/3 is 4/3. So 1 and 1/3. Right here. X is 0. This goes to 1. 4 times 1 is 4. X is 1. Here's the first. 12. Way up there. 2 squared is 9. 4 times 9 is 36. So what is happening right here? It just flips. I want to know what's going on over here. So this just increases rapidly once we hit positives. This is going to approach the x-axis but never cross. You can check once you put in negative 10. 3 to the negative 10, or 1 over 3 to the 10th. 3 to the 10th is a large, large number. What happens when your denominator increases to a large number infinitely greater than the top number? What happens to the value? Think about that. 1 over 1 is 1. 1 over 2 is half as much. 1 over 3 is 1/3. 1 over 4 is 0.25. 1 over 5. See how the bottom is increasing and the number, the value is getting smaller and smaller? Yes? Yes? Okay. So 3 to the 10th on the bottom is going to be a very large number on the bottom, which makes this an extremely small number. That is something you need to start to grasp. So this is getting ever closer to the x-axis but never crossing. Now, so here's the graph of this. What's the domain? The domain is talking about all your x values. Is there an x value that will not work, is my question. That's the easiest question to ask. Is there an x value that I can put in here that does not work? Or does all the x values work? So you're trying to get a non-real number. So that is my next thing. It's all real numbers. Yeah, you can put something. So that your domain is all reals. You just say the R with 2 little slashes on it like that. Those are real numbers. What about your y values? Do all y values work? Look at your graph. What doesn't work for y values? Well, I don't see any negative values down here, and I said it doesn't ever cross the x-axis here. So negatives, no. What about 0? Does it ever touch the x-axis? No. So why don't we say all positives? So y, your range, is going to be greater than 0. Or just say all positives. That'd be fine. I'd rather you say all positives. All right, let's do this one. Everybody do this real quickly, because I want to show you the graph. The graph's important. I'm out of time. I'm going to write them down for you so we can get going. First one is negative 2 over 27. Negative 1 is negative 2 ninths. 0 is negative 2/3. 1 is negative 2, and 2 is negative 6. I'm going to graph these. notice it approaches the y-axis from the right, really, but never, or excuse me, the x-axis, but never crosses the x-axis again. Again, any x value will work. So the domain on this one is all reals. The range is all negatives. You see that? And if you're not sure, if you think it's going to go over, then go put -10 in for x and see what you get on your calculator. It is not going to cross the x-axis. These won't. You'll have others someday that do. Okay, but these do not. But notice I said this was a growth section. Is this growing? What does B have to be? What is B here? Okay, so in this case, what we're seeing here is this factor here in the front is really what's causing the issue of this to go down the way it does. The negative makes it go down. Okay, but these are still increasing numbers. They're just negative. Okay, you'll see a decay. Excuse me, tomorrow. Here are these 1/8, or excuse me, 1/18. 1/6, 1/2, which is what A is, 3/2, and 9/2. And this one looks like this as you graph it, just like the first one. But notice all your B's on each of these three. I made them all the same on purpose. What's happening? This is 4, this is increasing like this is negative, so it's going that direction. My point is this, as it goes to the right, these numbers get big. These numbers get big negatively. Tomorrow, the decay means they're going to get very, very small. These pictures are going to be switched. This and the increase is infinite. Okay? But at a slower pace because of that. Yeah.
Is the domain and range the same for all of them?
Yes, it is. No, the range on this one is all negatives. The range on the first example 4 and 6 are all positives.
So that could be all negatives or all negatives or all positives.
Yeah, but you need to look and see what it is when you graph them.
Because part of them says to identify the domain and range.
Yeah, that's what you're doing. So you'd say like the domain, all reals, I'll take that for your answer. Range, all positives, that's what you should, this is what your answer should look like for domain and range. Your assignment, and then I'll answer any questions of those who have been working on this. Page 524, 4 to 32 evens.